Magic's Day everyone! In this video tutorial sessions, we will be visualizing molecules and polyatomic ions by drawing their LEDs and decide which structure is most valid for a given set of resonance structures. Okay, we also provided here the steps in drawing or depicting the Lewis electron dot structures of molecules and ions, and if you don't have your periodic table with you, then we can just refer to the one provided. So let's start. For example, you have the molecule NF3, okay? So NF3, that is your nitrogen trifluoride. So this is example number 1. So we need to draw the structure of NF3. So the first thing is for us to determine the placement of the atoms, and we must always remember that the least electronegative atom must be placed at the center. So the least electronegative atom, maybe for binary covalent compounds, is the one that's written first, okay? Or it's the only one, or there's the only one atom present. So for example, nitrogen, between nitrogen and fluorine, nitrogen is less electronegative than fluorine. So we consider nitrogen to be our least to be our central atom. Alright? Now the next step is for us to get the total number of valence electrons. So it's good if we have a listing. So nitrogen here, and then F. Okay. There is only one atom for nitrogen. There are 3 atoms for fluorine. Now nitrogen, if you look at the periodic table, it's found at group 5A, and therefore there are 5 valence electrons for nitrogen. While for fluorine, there are 7. Okay? So what we are doing here is to get the total number of valence electrons for all the atoms that are present. So this is 21, 3 times 7 plus 5 times 1. So this is 21 plus 5, that's 26 electrons all in all. So 26 valence electrons. The next step is to form single bonds between the attached atoms and the central atom, right? And then remember that each bond is participated by 2 electrons. So for each bond, we assign 2 electrons. Therefore, from the total number of electrons, we subtract 6. Okay, because there are 3 bonds, each bond having 2 electrons. So minus 6, you get 20. So those 20 electrons will now then be distributed first to the attached atoms so that they can complete their octet. Okay. Now take note that for example, in this fluorine, there are already 2 electrons being shared by nitrogen and fluorine. So therefore, in order to form an octet, this fluorine atom will need 6 more electrons. So this is 1, 2, 3, 4, 5, 6. And the same thing with the attached atoms. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and then 6. Okay, so this is 20 minus 6 times 3, since you used up 6 valence electron for each fluorine atom, and there are 3 fluorine atoms, so that is 6 times 3, you get 18. 18 more valence electrons. So this one, you'll have a remaining of 2 electrons. And then where do these 2 electrons go? Okay, to the central atom. So 1 and then 2, right? And the next thing here is we must make sure that the central atom already has a complete octet. So this is 1, 2, 3, 4, 5, 6, 7, 8. So therefore, we were able to draw the correct structure for a nitrogen trifluoride. All right? So maybe you can pause the video for a few moments to reflect, okay? And then what did we do there? So the next example will be having a double bond. Okay, a Lewis structure wherein a double bond is involved. So for example, we have OF2. So this is oxygen difluoride. So this is example 2. And let's see what we can make out of it. So between oxygen and fluorine, oxygen is far less less electronegative rather than fluorine. So if I'm going to draw it here, this is just F and then O and then F, right? The next step is to identify the total number of electrons. So that's fluorine and oxygen. There are two atoms of fluorine and there's one atom of oxygen. So fluorine has 7 electrons while oxygen has 6. Okay, so this is 14. 14 plus 6, you get 20 all in all. 20 valence electrons. And then after that, we form bonds 1, 2, 3, 4. Alright, so this is minus 4 electrons. You get 16. So what do we do to these 16 electrons? We are now on step number 4. Okay, we distribute the 16 electrons in order for us to complete the octet of the attached atom. So this is, take note that between oxygen and fluorine, there are already 2 valence electrons. So what we are going to do now is to add and add electrons to complete the octet of fluorine. So this is 1, 2, 3, 4, 5, 6. And then this is 1, 2, 3, 4, 5, 6. Alright? Now we expended 6 electrons for each atom of fluorine, so we get to subtract 12 electrons here. That's 6 times 2 is 12. So that's 16 minus 2. 16 minus 12, we get 4, right? 6 minus 2 is 4. So where do we place these 4 electrons? On the oxygen atom itself, right? 1, 2, 3, 4. And we try to check whether we have already completed an octet for fluorine and oxygen. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is minus 4 such that we won't have any valence electrons left. Therefore, we have arrived at the lead structure of oxygen difluoride. Alright, a few minutes to reflect. Now, let's have example number 3, wherein we have to go to step number 5. We need to form multiple bonds if necessary. So this is, let's take SO2. Okay, so SO2, that is one of the SOx. Okay, it comes from mufflers of vehicles. Now, that's sulfur dioxide, and then we know that our least electronegative atom here, or lesser electronegative atom, is sulfur, right? So this is sulfur, and then surrounded by oxygen. And then if we want to have the total number, so sulfur belongs to number 6, okay, group number 6A. So we have 6 valence electrons for sulfur, while oxygen also has 6 valence electrons. So 2 times 6, that's 12, plus 6, you have an 18. Okay, 18 as a total number of electrons. Now, we attach single bonds, or we make single bonds for our atoms to be connected to each other. So it's 1, 2, 3, 4, 18 minus 4. That is 14 valence electrons. So if you have 14 valence electrons, we need to complete the octet of oxygen. So each oxygen atom needs 6 more valence electrons. So 1, 2, 3, 4, 5, 6, 7, 8, including the bonds. 1, 2, 3, 4, 5, 6, 7, 8. Alright? Now, 6 electrons per oxygen atom. So there are 2 oxygen atoms. This is minus 12. Okay, 6 times 2 is 12. And then we are left with 2 valence electrons. The 2 valence electrons will be placed on our central atom. 1, 2. Okay, but take a look at what happens in the structure. If we take this into account, the minus 2, we are left with no more valence electrons. However, uh, the sulfur atom, which is our central atom, is not yet an octet, right? So 1, 2, 3, 4, 5, 6. It needs 2 more to become an octet. So what do we do? Okay, we choose from any of the oxygen atoms. Okay, let's say we'll have it here, and then share those electrons in order to form a to form another bond. All right, so that's it. So our final structure will be O, 1, 2, 3, 4. Then this pair of electrons has been shared as an additional bond to sulfur. So now we have a double bond. And then we have 2 electrons for sulfur. And then another single bond. And our oxygen atom. 5. And then 6. Alright? So if we check the octet of each atom, this is still 1, 2, 3, 4, 5, 6, 7, 8. Okay, still octet for this oxygen. Now sulfur has 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is correct. And then 1, 2, 3, 4, 5, 6, 7, 8. Therefore, we end up with this structure for sulfur dioxide. Right? So disregard this one. Okay, in the next part, we will be dealing with polyatomic ions and also an insight into resonance structures. So you can proceed to the next. For the meantime, you can take a break and have a stretch, take a cup of coffee, and view it later. View the next part later.